Hello and welcome. In this part, we're going to venture into uncharted territory. We're going to cover a new type of function, or new set of functions, called the hyperbolic functions. They'll be covered in more detail in your homework. So all we're going to do here is learn their derivatives. But not knowing about what the functions mean is not going to stop us from learning their derivatives. And one of the reasons that I feel that we're safe to do this is because the derivatives are so similar to the derivatives of the trig functions. So let's take a look. Here we have the derivative of the hyperbolic sine of x is equal to the hyperbolic cosine of x. So this SINH right here represents hyperbolic sine. And you could either say it out, hyperbolic sine, or the shorthand for hyperbolic sine is sinh, as in hyperbolic functions are a sinh. The shorthand for hyperbolic cosine is cosh. Like, oh my gosh, not another set of functions to learn. Alright, jokes aside, the h right here is part of the name of the function, so it's not a variable that can be cancelled off, or not written to make it into a trig function. It's part of the name of the function. So this is hyperbolic sine altogether. You can't break the h free from the n and the s and the I. It's part of the name. What's in that function is x. So if you look at these derivatives, hyperbolic sine, the derivative is just hyperbolic cosine, so derivative of sinh is cosh, and the derivative of cosh of x is sinh of x. So here it's almost the same thing with trig functions. You know, derivative of sine is basically cosine, derivative of cosine is sine. But here you don't even have to worry about the negative. With hyperbolic trig functions, at least sinh and cosh, you don't have to worry about that extra negative that you had with the trig derivatives. And then hyperbolic tangent, which I guess you could say tanh, is going to be hyperbolic secant squared x. I have no idea how to pronounce hyperbolic secant in a shorthand. I'm sure it wouldn't sound good if I tried. So, but just notice that the derivative of tangent of x before was secant squared x. So this just follows the same thing. You know, even if you add the h in there, it still applies. It's still the same shortcut, which is great. Nothing new to really memorize there. So with these in mind, let's go ahead and do example 7. Here we've got f of x equals negative cosh x minus 7 tanh x. So we'll write f prime of x, which means the derivative of f, is going to be, the negative will still be there. That -1 coefficient gets pulled out of the derivative, and so we just focus on the derivative of cosh x, which is sinh x. Then we have the -7 still there. Derivative of tanh x is hyperbolic secant squared x. And that is it. So hyperbolic trig functions, the best derivative shortcuts ever. Thanks for watching, and see you in the next part.